A relation is a relationship between two variables. It can be presented in a variety of ways: in words, as an equation, as ordered pairs, as a table of values, or as a graph. A relation can be linear or nonlinear. A linear relation forms a straight line when the data are plotted on the graph. In a table of values for a linear relation, as the values of x increase or decrease by a constant amount, the values of y also increase or decrease by a constant amount. Horizontal and vertical lines are exceptions. The equation of a linear relation contains one or two variables, and since the maximum sum of the exponents on any term is 1, the degree of a linear relation is always 1. A nonlinear relation does not form a straight line when the data are plotted on a graph. In a table of values for a nonlinear relation, as the values of x increase or decrease by a constant amount, the values of y do not increase or decrease by a constant amount. The equation of a nonlinear relation contains one or more variables, and the maximum sum of the exponents on any term is any value other than 1. So, the degree of a nonlinear relation is always a value other than 1. Graphs can be used to display two types of data: continuous and discrete. A graph of continuous data is represented by a solid line or curve to indicate that all the data values on a graph satisfy the conditions of the problem. A graph of discrete data is represented by isolated points on a graph that are not connected to indicate that data values between the points do not satisfy the conditions of the problem. Consider the relation y equals x. Some of the ordered pairs that satisfy this condition are -2, -2, 0, 0, 2, 2, and 4, 4. However, other ordered pairs such as -2.3, -2.3, 3/5, 3/5, or 3.5, 3.5 also satisfy the relation. The graph of this relation is an unbroken or solid line. This graph represents continuous data. Consider the relation defined by y equals x, where x and y are natural numbers. Ordered pairs such as 1, 1, 2, 2, 3, 3, 4, 4, and 5, 5 satisfy this relation. However, ordered pairs such as -2.3, -2.3, 3/5, 3/5, and 3.5, 3.5 do not satisfy the condition that x and y must be natural numbers. Thus, the points on the coordinate plane between 1, 1, 2, 2, 3, 3, and so on are not included on the graph. Therefore, the graph of this relation consists of a series of isolated, unconnected points. This graph represents discrete data. Some real-world scenarios can be represented by a linear equation. These types of situations involve the dependent variable increasing or decreasing by a constant amount when the independent variable increases or decreases by a constant amount. A scenario could be ticket sales for a charity fundraiser. For each person that purchases a ticket for the fundraiser, the charity receives $3. This means that as the number of tickets sold, the independent variable, increases by 1, the amount the charity receives, the dependent variable, increases by 3.